Okay, so what we have done so far is the linear regression and the quadratic regression. So right now we're gonna look at the exponential regression. Okay? So when we're talking about exponential, we're talking about things that change at a constant percent. When we talked about linear, it was constant first difference, right? Constant ratio. For quadratic, it was constant. The quadratic, it was constant second difference, right? But when we're talking about exponential, it's going to be constant percent, which means constant ratio. Okay? So in a table of value, what we're going to have, the growth or decay factors are equal to the basically to the base, right? So when we do the ratio in the table of value, you're going to have a constant ratio, and that ratio is going to be your base of your function. Okay? The graph resembles an exponential curve. And the equation is written in the form of y equals a b to the power of x, where a is your initial value, b is your growth or decay factor, and the exponent is your variable. So we covered this not too long ago, right? So just recall the vocabulary. So when I say growth or decay factor, I mean that ratio that goes right here, which represents B. But we talked about different ways to get to that ratio or factor, to get to that decay factor or growth factor. Remember when we said that if you have rate is given to you, so let's say you have a growth by 2%, right? What would be your growth factor? What did we have to do to find that growth factor?
With the variable?
If you have an increase by 2%, what did we have to do? What was the formula for a growth, exponential growth with a rate? Y equals what? A
I
1 plus
I.
I to the power of n or x or whatever. Remember that? So I is your percentage, right? Is your increase, how much you're increasing by with percentage. If you want to find your growth factor, you have to do 1 plus I. So when I do 1 plus I, that gives me my growth factor, which is in this case 1 plus 0.02, so my growth factor is 1.02. Do you guys understand that part? When we're talking about a decay, so we have to do 1 minus I, right? So if you're decreasing by, let's say, 2%, then you do 1 minus 0.02, and that becomes your decay factor. Now, we also talked about if the base is greater than 1, what does that mean? Growth or decay? Growth. So, what I was just explaining to you, that your growth factor, which is B, is equal to 1 plus your growth rate, which is I in decimal. So if you want to find what your I is, so if you want to find I, all what you have to do, you have to take your growth factor and you're gonna have to subtract 1 from it. So I is gonna be b minus 1. If b is between 0 and 1, then the relation is growth or decay?
Between 0 and 1?
Between 0 and 1.
Decay.
Decay. And then how do they get that growth or decay factor? To get that decay factor, which is b, I have to do 1 minus my decay rate, which is 1 minus I, right? So let's say, if you remember, your car is decaying by 10%, right? So then you have to do 1 minus 0.1 to get your decay factor. You guys remember that? Okay? If the question is asking you to find your decay rate, you have to do decay rate, which is the I, is equal to 1 minus your decay factor, which is b. Let's look at an example, because when we see the example, it will make sense. Okay? So I'm going to go to question number 2. And the question is asking you to determine the growth or decay rate. So that when the question is asking you for the rate, what letter does that represent?
I.
I. Okay? So it's asking you to solve for I. So if I'm looking at the first one, it's A equals to 500, 1.071 to the power of n. To find I, what do I need to work with?
1 plus.
So what's the formula? B equals 1 plus I, right? I am looking for I. Do I know what B is?
Yes.
What's B?
No.
What's my base?
The base is 1 point.
071, right? So this represents my base. Does that make sense? Now, I'm looking for I. So in order for me to find I, all what I have to do is I have to bring the 1 over and it becomes a minus 1. Right? So, I know that B is 1.071. To solve for I have to bring the 1 over, so that becomes 1.071 minus 1, which is going to be 0.071. And because we know the rate is in percentage, we just have to multiply by 100. Multiplying this by 100 gives you 7.1%. Are we okay with that? Now, for the second one, is it growth or is it decay?
It's decay.
It's decay because the B is
Lesser than 1.
between 0 and 1, right? Good. So, remember that with decay, to find B, what did I have to do?
1 minus I.
1 minus I. Good. I know my base, right? Remember that this is the base, right? I need to look for I. So what do I do here?
So it's going to be I is equal to 1 minus 0.92.
That's right. So basically, I'm gonna trade some spots here. So that minus I is gonna come over, so it becomes I. And then that b is gonna come over, so it becomes minus. Just because I wanna get rid of that minus in front of the I, right? Because I don't want the I to be a minus I, which is negative I. So it will be 1 minus 0.92, which is equal to 0.08, which is 8%. Does it make sense now to you? So you have to read the question very carefully. If the question is asking you for the factor, that means you're looking for b. If the question is asking you for the rate, that means you're looking for the percentage. We're all on the same page, right? We all understand what's going on here. Okay. Can I go back?
Yeah.
Now, in the question that asks which model represents exponential relations. So exponential relations, we know that we have to have a constant what in a table of value?
Constant ratio.
A constant ratio. So remember, with the ratio, I had to divide y2 divided by y1. Yes? So instead of subtracting in this case, I'm going to have to divide. So that means I have to divide 25 divided by 35. Then I have to divide 15 by 25. That's 0.6.
0.6.
Yep. And 5 divided by 15,
3.
which is 0.3. So looking at this, is your ratio constant?
No.
No? So that means it is not exponential. We okay with that? Now when we're looking at the second one, again, because the question is asking you to prove if it's exponential or not, so that means I have to look at the ratio. And the ratio says, so again, y2 divided by y1. So I take 64 divided by 51.2. And that'd be 1.25. I divide 80 by 64. That's going to be 1.25. And if I divide 100 by 80, that's going to be 1.25. So looking at this, what can you say?
Constant.
It's constant, so it is exponential. So exponential because
Ratio is constant.
yeah. So table of value, here are the things that you have to do. You have to do first difference, right? Because in this case, it's asking you specifically if it's exponential, so you know where you need to go to. But usually in a table of value, in order for you to be able to know what you need to do, you either do first, you start with the first difference. If that's not constant, you go to the second difference. If that's not constant, then you do your ratio. Okay? So there's three things that you need to do to know your answer. But once one of them is constant, you stop and you say, if the first difference is constant, right away you say it's linear. If you got your second difference constant, then you say it's quadratic. You don't have to continue to that ratio. Make sense? Okay. Then we're looking at the graphs. What can you tell me about the first graph?
Linear.
It's linear, right? So is it exponential?
Yes.
No.
Oh.
No. It's a straight line, so it's not exponential. How about the second one?
Or it can be exponential.
It does look like it's exponential. This could be ending up like this, right? So because it looks like it's growing fast, right?
Yeah.
It's a fast growth. Okay, so we're gonna say that this is exponential. It curves and it appears to be exponential. That's an A. Then if we're looking at the equations, so an equation of an exponential function, what must be variable for exponential? What must be variable?
The y is equal to a to the exponent of x.
So what's the variable? The
Exponent.
exponent, right? So the exponent has to be there. Okay, let's look at the first equation. So it's 10 2 to the power of x. Is this exponential?
Yeah.
Yes, because the exponent is
Variable.
a letter, right? Is a variable. How about the next graph or the next equation, sorry?
Not exponential.
Okay, it's not exponential because
The variable is a number.
It's the base.
what's your exponent?
2.
So what kind of function is this?
Quadratic.
Okay? So if I'm looking at this examples, I have to compare the initial value and compare the growth and decay factor. So I'm looking at the two equations of the two colonies of bacteria. So I have P equals to 102 to the power of T, while the other one is 103 to the power of T. So can you, before we graph, can you tell me can you compare the two? Compare the two equations for me. What's the initial value for the first one?
The initial value for the first one is 100.
100. How about the initial value of the second?
Same.
It's the same. So they both start at the same initial value of 100 bacteria. Make sense? Okay. Now if you're looking at the first column, or colony A, what can you tell me about the growth rate? It's doubling,
Yeah.
right? So it's doubling every hour in this case, or every minute, or every day. I don't know. It doesn't say every one unit. Okay? How about for the second one?
Triple.
Triple. So which one is gonna grow faster?
Second one.
The second one, right? So the second one is gonna have a steeper growth. So you're gonna see when you graph it on Desmos, you're gonna see that they both have that 100 start, but one's gonna grow like this, while the other one is going to grow faster. Okay? It's gonna have a faster growth because it's tripling. So after 1 hour, instead of having 200, you're gonna have 300. Right? Instead of having 300, instead of having 400, you're gonna have 900. So you're gonna see that it's gonna grow faster. So here's what I want you to do. I want you to take out, to open your computer, go to Desmos, graph these two, okay? And then you can copy them here. And I would like you to change, where is this? Change the initial value of colony to 200 bacteria. So it's gonna be P equals to 200 2 to the power of T, okay? And then tell me how is the graph gonna change. So you're gonna graph these two and then compare them, and then you're gonna graph this one and compare them. So you're gonna graph the 100 and this one and compare, and then you're gonna compare colony A to colony